Welcome to Organic Chemistry Lesson 3. Alkenes. Alkenes are hydrocarbons with double bonds. Alkenes are unsaturated carbons. They form a homologous series, and there is a general formula for alkenes, just as for alkanes, but now it is CnH2n. Alkenes are more reactive than alkanes. Alkenes with 2 carbons to 4 carbons are gases, and alkenes with 5 carbons or more are liquids. For interest's sake, ethene is the product that causes the ripening of fruits and the opening of flowers. This is ethene, 2 carbons, therefore eth, and ene because it is an alkene. Double bond. Propene is used in the industry for polypropylene and fuel gas. 1, 2, 3 carbons with a double bond is called propene. IUPAC names for alkenes. Alkenes got the suffix "ene" at the end. The prefix stays the same and the alkyl groups stays the same as for alkanes. Alkenes, example 1. The steps also remains the same. For this molecule, identify the functional group. There is a double bond, therefore this molecule must be an alkene. Find the longest carbon chain. Number the carbons and get to the positions of the branched groups. So there's your longest carbon chain with a double bond. That means this is an alkene. Number the carbons. 1, 2, 3, 4. Therefore bute. Where's the double bond? 2-ene. It is important to note that you have to indicate where the double bond is. Carbon 2. Alkenes, example 2. Draw the structural and molecular formula for 3-methyl-but-1-ene. So the first thing you do is identify the functional group, which is an alkene. Find the longest carbon chain. Here it is. 1, 2, 3, 4 carbons because it says but. Now you have to add the double bond and the methyl. The double bond is at carbon 1 because it's 1-ene. And the methyl group is at carbon 3. This is a structural formula, so you have to show all the bonds. Molecular formula, you only count the amount of carbons, 1, 2, 3, 4, 5, and the amount of hydrogens, 10. Example 3. Give the IUPAC name of this molecule. Identify the functional group. There is a double bond, therefore it must be an alkene. Find the longest carbon chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you have 5 carbons in your longest chain. Number the carbons. 1, 2, 3, 4, 5. And now you identify the position of the double bond and the branch. You have a branch at carbon 3 with 2 carbons, therefore ethyl. And you have a double bond at carbon 2, therefore 2-ene. So 3-ethyl pent 2-ene. Example 4. The IUPAC name of this molecule. Now you have to draw the molecule so that you can see what's going on. There you go. CH2, CH2, CH, CH. There have to be a double bond between these 2 carbons. Why? Because a carbon always forms 4 bonds. So there isn't any hydrogens bonded to these two carbons more than these two and that one. And therefore you need a double bond there, otherwise the carbons does not have 4 bonds. CH2, CH2, CH3. So now you can count your carbons 1, 2, 3, 4, 5, therefore pent. And where's the double bond? At carbon 1. Example 5. The IUPAC name of this molecule. You should identify the functional group. There's a double bond, therefore it must be an alkene. Now you have to find the longest carbon chain. Let's count. 1, 2, 3. 1, 2, 3, 4. And number your carbons. There's your longest carbon chain. 1, 2, 3, 4. And you have a substituent at carbon 2. So the name should be 2-methyl, but because there's 4 carbons, 1-ene because the double bond is at carbon 1. Example 6. Which one of the following compounds cannot be an alkene? Here you need to use your general formula for alkenes. So you have to study it. CnH2n. So now A, CnH2n. So A is an alkene. B, C3H6. So B is an alkene because 2 times 3 equals 6. Let's look at D. C4H8. That is also an alkene. So therefore the answer can only be C, since the question is which one of these cannot be an alkene. The answer is then C, because 2 times 3 is not 8. Thank you.